Okay, in this module we're going to do an inspection of a fan, and we're going to take a look at a couple different fans. So as we walk up to a fan, we're looking at the condition of the base, the cleanliness of the area, the lighting conditions, how solidly is that fan bolted down. So as we walk up on it, we look at that. This fan is fairly clean. It does look to be well supported, a lot of concrete, 5 times the mass of the machine. The bolting looks good, although we don't want to see spare parts and spare bolts laying around. That should be cleaned up so that if something does come loose, then when you see a bolt laying there, you know that it's just come loose. We look at the condition of the rest of the bolt. You can see there's some feathering, there's some actual leakage from that fan, so it's a dusty product that's being blown through there. We just want to monitor that. We look at the suction and the discharge piping. We're looking for any signs of leaks. We're looking at the condition of dampers. We're looking for the condition of hangers. We take a look at the local instruments, make sure that the local instrumentation is functional so that we can verify what's being read back in the control room by the field personnel. Okay, we want to see at least, we want to see consistency in the bolting, same grades, same washers, same number of threads sticking out from underneath the nuts so that we are confident that we have the same amount of clamping force. All right. Again, stepping back from the machine, it looks fairly clean, but you can see that the base has been hit a couple of times and is cracked. As well, when you get closer up, you start to see a gap in between the steel and the concrete. Now, is it warping? Has it cracked from vibration, from buildup on the fan wheel? Here we go to a different fan, and you see this one doesn't have a concrete base. It's just being held up by all thread. I'd be putting my hand on this machine and keeping a close eye on it just in case vibration might be higher on this one, maybe because it doesn't have as solid a base. When we were at the first fan, we recognized that it didn't seem like there was a lot of air movement. So we take a piece of paper. That paper should be pulled up against the end bell of that fan, but it's not. So it makes us wonder what the condition of the fan itself is. So at that point, investigate a little further, use a strobe light in order to look into that while it's running. And we verify that there is no fan blade on this motor. And so if the motor was running hot, that would be the fix that I would go to that one, is get it written up to get a fan put on that one and bring the temperature down. Okay. So here's another fan that we go and take a look at as we walk up to it. We're taking a look at the condition of the base. It looks good. Taking a look at the condition of the coupling and the guard. You're getting a strobe light effect from the video that makes it look like it's very slow rolling, but it is actually running closer to 1800 revolutions per minute. So we're looking at the condition of the guarding, the condition of the base, the condition of the bolting, the handrail, the ladder, and everything that I need to use to get up to there. Make sure that everything's in good, serviceable condition. And from this side, everything looks pretty good on this fan. And what's interesting, though, is that this is the easy side to get to. Then you start walking into the more difficult side of the fan, walk around it, go all the way around the machine, and look at everything. And when we start looking at the condition of the base, where the steel base is mounted to the concrete, now you can begin to see what appears to be some warping and some corrosion. Okay, and so you can actually see a bow in that. You can see a bow in that base. And so as you take a look at it, it's like, was it due to vibration or other things? But you know, this should be noted, and it should be looked at. And is it a problem? And then what are we going to do about it to repair it? Okay. So now we get into going from the look, listen, and feel. Go grab our instruments. We take the strobe light, and we go check the motor nameplate speed, and then use the strobe light to verify that the machine is running at or near its nameplate speed. They'll give us an indication of whether it is overloaded or not. The condition of the shims, should see no more than 4 shims underneath the foot there. And since this machine has been shimmed, it probably have taken into consideration case distortion or soft foot. We go ahead and grab the temperature gun, checking the inboard and the outboard bearing. Here we're looking at the outboard bearing. It should be 140 Fahrenheit or below. It is winter in this shot. We know that there's not much airflow moving across there. If the fan were to get loaded up more, or it's in the hot summer sun, or all of the above, and it starts to run over 140 Fahrenheit, we know that what we could do to bring the temperature down is not put an air horn on it, but actually to go ahead and get the fan fixed and repaired. And so, you know, once we know what the root cause of the not moving air is, we can make a good decision. Now we go ahead and grab our vibration pen, and we can check on the horizontal velocity and GE. You know, 0.06, 0.07. AC induction motors, I'm used to seeing usually velocities 0.1 or below. So we go horizontal, vertical, and then axial would be in the direction of the shaft. And now we move to the inboard bearing, and again you can see, you know, 0.06, 0.07 readings, quite good on this machine. Okay, it's acceptable. It's not quite in a precision state, but it's certainly, we've certainly seen worse. And now we go ahead and say, okay, well, I wonder if how the one is doing that's sitting on all thread. And again, since it's not as solid a base, I would be concerned that, well, maybe there is a potential for vibration, higher vibration readings. And here's a vibration reading of 0.7.